Good morning, Algebra 2. Mr. Woe here. And as usual, are you with me? Well, today's video is the second part of section 11-3, solving radical equations. And today we'll do problems number 6, number 10, and number 12. And I really want to encourage you all to take a moment and work those out. Do it in pencil in case you make a mistake. You can erase it, work it out, and come on back and resume the video and see how you did. All right, so let's look at our next three problems. I did all three of them on one sheet of paper. I didn't do any excessive writing, so I'm just going to go into working the problems out without going into a lot of details. Okay, so here's our first one. We have the square radical equation, in this case, of the square root of 45 minus 9x equals x minus 5. So the next thing we're going to do is we want to get rid of our 1/2 power, which is square root. So we want to take the square root of both sides. That's what's done here. Then the next line is taking the x minus 5 squared and doing x minus 5 times x minus 5. The next line is the application of the FOIL method from x minus 5 times x minus 5. Then we go ahead and set it up as a quadratic equation by subtracting a 45 from both sides and adding a 9x to both sides. And now we're given x0 equals x squared minus 20. All right, now the right side, once again, you can either work this out by factoring or by the quadratic formula. But this one works very nicely with factoring because if you look at here, what are the factors of negative 20 whose sum is -1? And we found it to be -5 and +4. So this is the factored form of x squared minus x minus 20. Apply the zero product property, which is x minus 5 equals 0 or x plus 4 equals 0, and then solve for the two equations, solve for x. Now the next thing we do is we take the time and see if those solutions 5 and -4 work in our problem. And you go back to your original problem. Anywhere you see an x, let it become x is 5 and see if the left side does equal the right side. Then let x become -4 and see if the left side does equal the right side. And if you do your math mentally, we're dealing with number 6. If you do your math mentally, you will find out that these are your solutions. Actually, we'll see that only one of these will be a solution, okay? So we're going to find out that x equals 5 will be the solution to this system. I don't know why I call it a system. This is a radical equation. So the solution is x equals 5. It can't be -4 because if you do your math, you're not going to get the same answer. Okay? So our solution to this problem is just x equals 5. Okay, let's go to, again, I got it set up. We'll do number 10 now. This one's a little bit different than the other ones. So first, here's our problem. We have 2 times the cube root of 3x plus 2 equals the cube root of 4x minus 9. Again, we have a radical isolated. We could do something here, but it's not necessary. I don't want to add any more confusion to you. So what we're going to do is just keep it very simple. Again, the next line is to get rid of a cube root. We cube it, so we cube the left side. Also, we got to cube the 2. That's where I get the 8. And if you cube the right side, you're left with 4x minus 9. Then we have ourselves our equation. Go ahead and solve for x. Apply distributivity. Subtract the 16 from both sides and subtract the 4x from both sides. And now we're left with x equals negative 5/4. Again, we have to check our solution mentally. So we take x equals negative 5/4, plug it into x in either side of the equation. Look and see if the left side's value is the same as the right side value. In this case, it works. So our solution to this problem is x equals negative 5/4. Those of you that use the calculator, you'll probably get negative 1.25. That's okay. That is number 10. All right, let's look at number 12. Number 12, we're given the cube root of x plus 5 equals x minus 1. Again, probably by now you guys have a good grasp of this. You're probably saying you're very confident now. Give yourselves a big high five. I'm so proud of you guys. So let's work this one out, okay? Cube both sides. That's what we did on the next step. X minus 1 cubed is, once again, is x minus 1 times x minus 1 times x minus 1. Again, I went ahead and did FOIL on this part, and then distributivity down onto this line. Subtracted a 5 from both sides and subtracted a x from both sides, and we're left with 4 terms. 4 terms for right now tells us we can use the grouping method. Maybe later on, especially when you get to pre-calculus, we won't be able to use the grouping method. We'll probably have to use the rational zero theorem. We'll talk about that one if in our year if we get to it. All right, group the first 2 terms, group the second 2 terms, GCF from each group. Go ahead and factor out the x squared minus 3. Again, just as a quick remember, if I cancel out the x minus 3, it'll be x minus 3 times x squared plus 1, x squared plus 2. Again, I did this problem a little bit differently than I did the other ones. Okay, it's the same thing because of commutativity. Set each factor to equal 0. That is the zero product property. Take the corresponding equations and solve for x. Again, the solution to this problem will be x equals 3. Well, the reason we know why is because 2i is a non-real 0. Again, we let x become 3. We plug it into our problem, and our answer is x equals negative 3, or x equals 3. Now again, I think on a little bit of a sidebar here, a lot of our problems we have been getting solutions. There may be some problems that you'll run across that you may have, like here, like this problem right here, we may have 2 solutions. We may find out that, like this problem right here, we know that x can't become negative 4 if we plug it into our equation above. And we may even find that maybe this other one may not work either. Now, if you run into a situation where you're, from application of the zero product property, that you come across 2 solutions and both of these solutions do not work into that quadratic, that will tell you that the solution to this problem, there will be no solution. I just thought I'd throw that out there with you. I'm not certain there's any problems like that in your homework, but that's just something you can remember when you guys are studying. All right, guys, thank you so much. This is, again, I'll take any feedback from you guys on videos. I'm doing the best I can to help you out. Again, I love you, and I'll catch you on the next section. Bye.